Hi everyone, welcome back to the channel. And today we're going to solve Leetcode daily challenge, problem number 106. Construct binary tree from Inorder and Postorder Traversal. Before starting this question, we need to know what is Inorder and Postorder Traversal. So basically, these are the two techniques which we use to, traverse any tree. So in order traversal, basically you traverse the left side first, then the root node, and then the right side. Okay. As the name suggests, the root is in between the left and right children's or subtrees, you can say. And in the post-order traversal, the root comes after left and right subtree. So the traversing would be left subtree, right subtree, and then the root. Okay. So now moving to the question, we will be given two arrays in order and post order, where in order traversal, like in an in order array, we will get the in order traversal of a binary tree, and in post order, we'll get the post order traversal. And using these two arrays, we have to construct a binary tree. Okay. So what we'll have to do is we will basically be using both the arrays, both the elements to construct this kind of a tree. So what we'll do is, as we know, in the post-order traversal, the root comes at the very end, right? So if you see this example, in the post-order traversal, the main root or the high-level root comes at the very end, right? Because let's say this is the left subtree, this is your right subtree, and then we have the root. So what we'll do, we in every step, and one more thing, like we'll be using recursive method for this. So at every step, we will pick the last element from post order. Okay, but now you have to recognize what all element will come on the left side and what all elements come on the right side. So for that, I'm going to use our in order array. So we pick the element, we will check the index of it, and everything left to it will come under the left subtree, and everything on the right side will comes to the right subtree. Okay. Then we'll call the same method again and again on the on both side of the trees. So yeah, this is it. Like this is what exactly you have to do. So let's move to the solution, and I'll explain what we'll be doing on the code section. So first of all, I don't want to traverse this in order again and again for the indexing. So to solve that, I'll be preparing a hash of indexes. What we will do is we'll keep the value as our key and index as your values, like value in the sense, value in terms of key value pairs. And what we'll have to do is we'll have to use enumerate on in order. Okay. So when you use enumerate, you get index and value from this method. So this will basically prepare a hash map of your value and indexes. Okay. Next comes the part where we wanted to recursively call a method, right? So I would like to define that method. So let's name it helper. Okay. Now let's think about the parameter we would need. So we don't need post order, right? Because we have that as in as your main parameter of this function. But your in order array is getting changed again and again. Basically, the size or the window of in order will change. So we would need something or some parameter to recognize that. So I will expect two parameters. Let's name it left and right, which will give us the boundary to be traversed under in order. Okay. And in this, like whenever we use two pointer or anything of this sort, we just check if our left is greater than right. This is not a valid condition, and we will just simply return none from it. Okay. Now, next comes the part where you want to create a node for the current element or create a new root, let's say. Okay. So for that, let's initialize a new variable called new root. Okay, and to create a node, we have this class called tree node. And as we saw, like whenever we will pick a new root, this will be done using the post order array. So from post order, I'll pop the last element from it, and this will create a new root for us. Now what? The next step was to divide the in order array, right? So what we'll do is we will check what was the index of this new root value. Okay, so let's name it in order index, and we wanted to check the index of this value, right? So index of new root dot value. Done. Okay, now comes an interesting part which I forgot at the time of explanation. So we will have to, like, when once you divided this your left and right sub tree elements. Now there is a specific pattern in which you'll have to create your left and the right subtree, which will be you will have to first create the right subtree. The reason is, let's say, let's take this example. We had Okay, in post order, we created our root node using three. Okay, and we divided your left and right subtrees. Now, if you see, the next root node will be 20, right? Which is the part of your right subtree, and this will be the case always. Like no matter what it is, you'll have to create your right subtree first. Okay, so to do that, what I'll be doing is like very simple steps. New root. So basically, we are adding right subtree to this, and we will recursively call the helper function. And how will you call that? So basically, on the right side, we will have all the elements after this index till your right till your right boundary. Okay. And similarly for the left side, you will have all the elements from left to the in order index -1, and we'll just return your new root. And at the end, you just have to initiate this helper function with what, like 0 as your left pointer and length of in order -1 as the right boundary. So let's check out the test cases. Okay, in order. Okay, there is a typo somewhere. What is it? Where is it? Hmm. In order. Awesome. So the test cases got clear. Let's submit for further evaluation now. Awesome. So like we were able to successfully complete this problem, and we performed really well, I would say. We outperformed 95.83% of the submitted solutions. So yeah, thanks a ton, guys, for watching out the video, and stay tuned for the upcoming ones. Don't forget to subscribe to the channel. Thank you.